Hey guys, welcome to day 54 of 100 Days of Code. Today we're going to be moving on to a new topic, and that is going to be web development. And we're going to be working on this for the next few days as well. Now, there's quite a lot to cover today. We're going to be talking about the command line, Python decorators, as well as web development using Flask, one of the most popular frameworks for creating websites using Python. Now, before we get started though, you might be thinking, well, I already know how to make websites. I learned about HTML and CSS on days 41 through to 44, so I already know how to make websites. So what exactly is it that you're teaching me now? Well, if you think of a simple website just contains HTML and CSS. Now that is also what we call the front end. This is the beautiful mermaid that the user gets to see. Now, for the website to actually have some functionality, for example, if you're building a web app instead of just a simple display website, then it's also got to have a backend. And the backend is the part that we're going to be learning how to build right now. So if the front end is just the part that displays information to the user, the back end is the part that does a lot of the business logic, a lot of the calculations, and a lot of things that we've been doing with Python. Now, when people talk about full stack web development, which is a term that you would have heard of if you were searching for web development jobs. Now, full stack basically just means front end and back end. So somebody who can deal with both front end and back end technologies. Now, usually there's quite a few languages that are used for the front and the back end. So the front, it's usually HTML, CSS, and JavaScript. HTML gives the website structure, CSS gives it style, and JavaScript allows it to have some sort of interactivity. Now, the backend can also be created by a bunch of different languages. And here it's more of a choice. You could choose between JavaScript, Java, Python, Ruby, and there's a whole bunch of different languages. To make it even more complicated, in addition to languages, there's also different frameworks that you could use for the front and back end. So some popular frameworks you might have heard of are things like Angular and React for the front end, and Node and Flask or Django for the back end. So these frameworks are basically tools that already come with a lot of code pre-built for a lot of the common functionalities that you find when building the front and back end. So that way we don't always have to reinvent the wheel, and we can simply just use the wheel and build a bicycle or build a car or build a scooter and whatever it is that we want. Now, when we're considering Python backends, there's a whole myriad of different frameworks that you could choose from. For example, Flask, Django, Bottle, CherryPy, Pyramid, and a whole bunch more. But the most popular ones, if you look at job search anyways, is Flask and Django. Where Flask is better suited to beginners and also small projects, and Django suited much more to larger commercial projects. In order to build out a website which has a front end and a back end, we have to kind of understand what exactly is the back end. There's three components that you really need to understand when it comes to the back end. And that is the client, the server, and the database. These three components together will determine how your backend will work. Now, firstly, the client you can sort of imagine just as a user going onto a browser. This is the client side. This is the part that faces the user. And then there's the server. So you can think of the server as basically just a powerful computer that's hooked up to the internet and it's on 24/7, always ready to receive requests over the internet. Finally, you've got the database, which is kind of like a souped up spreadsheet where you're storing all the information related to your website. So let's say the client wanted to go to google.com. Well, when they type that into the URL bar and they hit enter, that gets sent to the server as a request. And this goes across the internet to this other computer, and this server has to respond. And it responds by sending over the HTML, CSS, and JavaScript files that it has for that particular website. And once that gets sent back to the browser, then that can be rendered by the browser as the actual web page. Now, if you're a website that has a lot of user data or different types of data that could be requested by a user, then usually you'll have a database. So when the client requests, for example, to see all the tickets they have on Eventbrite, well, the page that they're viewing, that is the front end, that is the client side. But in order to render all the tickets they have, the client makes the request to the server and the server fetches the data from the database. Once it gets the data back from the database, it puts the data into the HTML, CSS, and JavaScript files, and then it sends the whole bundle back to the browser to be viewed by the user. If this whole process seems a little bit convoluted and complex, don't worry. We're going to be diving deep into creating our server, creating our database, and we're going to be creating all of these parts from scratch, step by step ourselves. So at the end of the web dev section, you'll find that if you come back to this video, everything's going to make a lot more sense. Now, in order for you to have a good overview of what the whole system looks like, I like to use the analogy of a restaurant. So imagine if you have a restaurant and you've got the front of house, which is where the tables are, where the customers sit, and then you've got the kitchen, which is where the chefs work and where you're creating all the dishes, and finally you've also got the larder, which is where you store all the ingredients in the fridge or on the shelves. Now, this front of house part, which is where the user sits in, is the client side. Now, in the middle, we've got the kitchen, which is the server. And finally, we've got the larder, which is basically the database of ingredients. Now, the client side is completely separate from the rest. So as a user, when I go onto a website, I'm not interacting with the server or the database directly. Instead, I'm interacting with my browser, which is on the client side. Now, when you go to a website and you request to see some piece of information, for example, you log into Spotify and you want to view your playlists, what actually happens is, you don't have the chef sort of cooking up the dish in front of you on the client side. No, instead, what happens is that the server fetches the relevant ingredients from the database, so the data that's related to your Spotify playlist, and then it takes that data and it renders it into a HTML, CSS, and JavaScript files. And then once that end product is created, it ships it out to the browser on the client side, which you as the user can now view. So this is basically an overview of how our front end and our back end interact in order to create a website experience for people. And in the coming lessons, we're going to be building out each of these parts, and you're going to see in greater detail how they work together. So head over to the next lesson and we'll get started building our very first website. All right, let's get started developing websites using Flask. Now, Flask is one of the most popular web development frameworks. But what does it mean to be a framework? Well, we've seen libraries before, like Beautiful Soup, tools that we can use and tap into whenever we need a particular piece of functionality. Now, a framework is a little bit like a library in the sense that it's a package of code that you didn't write, but it's also got some differences. So here I've got a graphic from difference between .NET, and one of the biggest differences is the fact that a library is something which you call upon to do something specific, whereas a framework is something which you have to abide by their rules, you have to use their architecture, and when it comes to triggering some sort of functionality, it's the framework that calls upon your code. So what does that mean? Well, remember when we used the requests library and we would say something like requests.get, and then we would tell it which web page to go and fetch. Well, this is us tapping into that library and then giving it a command to do something. Now, when we're working with a framework, it doesn't really work like that. We don't really say, hey, framework, do this thing for us. Instead, we make sure that our code is defined in a way that the framework wants it to be. And then when the time is right, the framework is actually going to call our methods instead of us calling the framework. All we have to do is to plan ahead for certain situations. If it was this situation, what do we want to happen? If it was that situation, what code should be run? So it might be that all you have to do is just write some functions like hello world, and when the user goes to the website, then it's going to display this text, hello world. Let's try this in practice. Now, by now, you would have known that as developers, especially now that we're in the advanced stages of becoming a Python developer, the most important thing when we approach a new tool or a new technology is to read the documentation. So Flask actually has a really good piece of documentation in order to tell us how to get started quickly using Flask. As you can see, they've described what a minimal Flask application looks like, and this is a very simple server set up with Flask. So let's go ahead and copy this code, and I'm going to create a new project which I've decided to call Hello Flask, and then in this project folder I'm going to create a new file which I'll call hello.py. Now it's important that the name of your file does not conflict with the name of the framework or library, in fact. So for example, if I was to create a file called requests.py and I had imported the requests library, and then I tried to do something like request.get. Now, when I run this, because the name of my file conflicts with the name of the module, what will happen is I will get this error. And it might be a little bit confusing because it says, well, request has no attribute get. Well, we know it does because it's in the documentation. And the reason why we're getting this error is because we've named this file the same name as the module. So this is something that happens to a lot of people. So make sure that you don't commit this mistake, and you could name it anything like main or server or hello in our case. Notice that now if I change the name, it actually automatically changed the import, which is not what we want. We want the import to be requests, and we want to make sure that we install our package requests. And once that's done, you can see our module and our file have completely different names. So now if I run this file, it works perfectly and it ends with exit code 0, which means everything was successful. So now I'm going to go ahead and delete this file and go back to our hello.py. Now inside our hello.py, I'm going to paste in the minimal Flask application from the Flask documentation. So paste that right here. And as you might remember, there's several ways that we can install new modules. So in this case, the module is Flask, and we can either click on the red light bulb to install this package. Alternatively, we can go to PyCharm, Preferences, and then go to our project and into the interpreter to add the Flask package, like this. Now, if you have the PyCharm Professional Edition, there's additional tools to make it easier to install Flask into your project and to work with Flask projects. But because we're using the free Community Edition, I'm just going to go ahead and dismiss that pop-up. So I've shown you two ways of installing a package. Now I want to show you the third way, which you might come across if you're looking at the installation. So notice here, in order to install Flask, they're using pip install Flask. So pip is something that allows us to install Python packages from PyPy. So any package that you find on pypy.org, you can install using pip. And what we have to do is to type in the name that you see right here. For example, if we want to install Flask, then it's pip install and it's the capital F for Flask. So we can copy that into our clipboard, and if we go to the terminal tab at the bottom, we can paste that instruction in here and hit enter. Now it should have successfully installed Flask, and once I dismiss that, you can see my errors go away. So all three methods work. I personally prefer the red light bulb just because it's much quicker. It's just 2 clicks rather than typing a lot of code. Now, once we've installed Flask, we can go ahead and add some space to get rid of all the warnings from PyCharm, and we can go ahead and run our project. Now, as soon as I run the project, you can see it tells me the process was finished with exit code 0, which means everything was successful. But where's my server and where's my website? So let's go back to the quick start to see what we actually have to do in order to set up our server. So to run our Flask application, we're going to firstly need to export a environment variable. So in previous lessons, we've talked about environment variables, but basically this is going to tell the Flask framework what is the name of the file that contains our server. So in our case, as well as in the quick start, the name of that file is hello.py. So we basically have to point to that file to get Flask to be able to recognize it and to use it as the server. So on Mac, we're going to type export space, and then we're going to put in the name of the environment variable, which is Flask_app, and it's all caps. And then with no spaces, we've got a equal sign, and then the name of our file, which is hello.py. So now when I hit enter, that's going to add that environment variable under the name that Flask is expecting, which is flask.app. Now, as it mentions in the quick start, if you're on Windows, the keyword is not export, but instead it's set. So again, inside your terminal down here, you're going to type set, and then you're going to put in the name of that environment variable, which was Flask_app, and then with no space, equals, and it's our hello.py. And once you hit enter, it should give you the prompt again, indicating that everything went smoothly. Now, once we've done that, the next step is to simply use the Flask command called run. And when I hit enter, you'll see that it's created my server. So it's serving up the Flask app that I've created in hello.py. And we get a warning telling us that this is a development server and telling us that if you want to actually launch it as a product, don't use this development server. There's a few steps you have to carry out if you actually wanted to make this production ready and ready for the internet and customers. But in our case, we are developing, so this is perfect. And it tells us where to go and find our website. So if you imagine that Google is at http://www.google.com, well, this is the address of our website, and it's being served by our computer. So when you're trying to get hold of a website on the internet, then you have to point towards the IP address of that particular web page. But because we've created our server locally and it's being served on our own computer, then this is basically the local address of that website. Now, a neat thing about PyCharm is if I simply just click on this link, then it's going to launch my website in my browser. And you can see right up here, we've got Hello World showing up, which is the same as what we've got here in this method. So that proves that we've successfully managed to create our very first web server using Flask, and it's able to serve up our very first Flask website. Now, if you go ahead and open up the Chrome Developer Tools and you go to Elements, you can see that what we wrote here, which is just a string, was actually converted by Flask into full HTML. It's got the HTML tag, it's got the head tag, it's got the body tag, and we didn't have to do any of this. We just told Flask what we wanted to be returned onto the page when the user goes to the home page, which is just the web address plus a /. Now, the very last thing to remember is once we're done with our server, because it's still ongoing, it's still waiting for a client to hit up this website, we have to get it to stop waiting. So we can quit by holding down Control and then pressing C. And you can see this takes us back to our prompt where we've got our name and our project. Now, if you don't stop it and you try to run two Flask applications to the same address, then the second one is simply not going to run. So just be aware that once you're done with your server, hit Control-C to quit. Now, in the next lesson, I want to talk a little bit more about the commands that you can use in the terminal, because this is called the command line. And just as here, we use the command line to run our Flask application, to export our environment variables, we can also do other things like create folders, create files, move files around. It's actually a very, very powerful way of interacting with our computer. That's what we're going to do in the next lesson. So for all of that and more, I'll see you there. Now, in the last lesson, we saw how to get up and running with our brand new Flask server. In this lesson, I want to take it back a little bit and talk briefly about some of these commands that we put into the terminal here. Because the terminal is actually a really powerful tool. And it's something that's also referred to as the command line. And it's a way of typing in commands one line at a time in order to control our computer. The command line is also known as the shell. So what exactly is a shell? If you think about your operating system as a pistachio nut, then the kernel, so the actual pistachio, the thing that you're going to eat, I'm really sorry about all the food analogies. You can clearly tell that I'm pretty much hungry most of the time when I'm recording these videos. But let's get back to the topic. So if your operating system is a pistachio, then the actual nut is the kernel. And in computing, the kernel refers to the actual program that interfaces with the hardware. So it's the core of your operating system. Now, the shell of your pistachio, or the shell in computing, refers to the user interface for you as a human to be able to interact with the kernel, and in turn with the hardware of your computer. And there's two variants to the shell. There are graphical user interface shells. So for example, when you open up Finder, you're using a graphical user interface to access and find your files. But there's also a command line interface, which is what we're going to be talking about and what we're going to be learning about in this module. So this is an alternative way of interfacing with the kernel. Now, it can seem intimidating at first, but I want to show you that it's actually super simple. And once you understand it, you're going to see that it's actually a really, really useful tool at your disposal. A lot of things that you can do with the command line can be done using the graphical user interface. So why use the command line at all? At the end of the day, what it all boils down to is about greater control. And in your journey of becoming a better developer, you will need to understand and exert more power over your tools, that is the computer hardware. But on a more day-to-day basis, you will find that if you're a regular command line user, that it's actually easier and faster to do a lot of really common things. If you're a Mac user, you've actually got a dedicated terminal application. So if you go to Spotlight and hit the search button and look for the terminal and hit enter, you can see that this is the actual terminal application. Now, I've styled it up to look a bit more like a hacker because I like scaring people in Starbucks, but that's not the only thing you can change. You can change the color of your terminal. You can also change the type of shell you're using. Currently, if you're running macOS Catalina or above, so Big Sur or any of the future operating systems, you're going to be using ZSH, which is now the default Mac shell. Now, if you're on Windows, however, the default shell is the command prompt. So if you type in to search for the command prompt, you can see this is the app you need to launch, and this is your command prompt. For the most part, you can type in the same commands on Windows and on Mac, and it will work on both. I want to show you some common things we can do in the terminal. Here I've got my terminal, and the address of the terminal is determined by the part that's just before the prompt. So at the moment, it's a tilde on my Mac. So there's a couple of things I want to show you that you can do with the terminal. The first thing that's really useful to know is where am I in my file path? And to do this, we have to write pwd, print working directory. And this tells me where I am. Once you've opened up your Finder, as you can see up here, go to View and then go to Show Path Bar. And this is showing us the path from our hard drive /users/Angela, which is exactly the same location as what I've got now in my terminal. So the print working directory is really useful for you to locate where you are. Similarly, on Windows, you can see when I do print working directory, it tells me that I'm in the C drive /users/my username. So C drive, users, username, right here. The next command that is really useful is ls, which stands for list. And what this does is it will list all of the files and folders at your current working directory. So it's going to list everything that's in this current location where I am at, basically this. So if I go ahead and hit enter, you can see all of the same folders showing up as it does in Finder. pwd and ls are really useful for finding things out, for displaying things, but we can also use the terminal to move around in our computer. And we do that using the cd command, which is change directory. So if at the moment my working directory is users/Angela and I want to get into my desktop folder, which is clearly one of the folders that I can access, then I can simply say change directory to desktop. Now, one of the things you can do to prevent yourself getting repetitive strain injury and typing a lot is you can type the start of the folder, so for example, desktop DE, and then hit tab, and it'll narrow down on the possibilities that you can go to. So there's development or there's desktop. So if I add one extra S and I hit tab, it's now going to automatically insert the folder that I'm looking for, which is desktop. So now if I hit enter, you can see that this part before my flashing prompt has changed, and it's changed to the desktop. So now if I do pwd, you can see I'm now in users/Angela/desktop, which is the equivalent of double clicking on this basically. On my desktop, what if I wanted to create a new folder? Well, we can do that using the make dir or make directory command. So we're saying make directory and then we give it a name. So let's say I want to call this test. Then I'll just say make dir test and notice the location where you're at. So I'm going to be making this test directory on my desktop. And as soon as I hit enter, there you see it. It's created that folder from scratch. So now here's a question. If you wanted to navigate into test so that when you print the working directory, it's going to output users/your username/desktop/test, what would you do? What would be your command? Pause the video, have a think about that. All right, of course we have to change directory because at the moment we're in the desktop, which is this. And if we want to go inside this test folder, then we have to cd into it. So cd into test. And now we're inside the test folder, and if I hit pwd, you can see this is where I'm at. Now, once I've cd'd into this new directory, I'm going to create a new file in this directory. To create a new file, the command is a little bit different from creating a new directory. The keyword is touch, and after the keyword there's a space, and then we can provide the name of our file. So let's say that we want to create a new Python file, which we'll call main.py. Now what it's going to do is create this file called main, which is a Python file, and it's going to do that inside the test folder. So let's hit enter, and there you see it. There's our Python file created without any clicking or dragging, completely done with our command line. So we've seen how we can create folders, how we can create files. And by the way, if you want to create a different type of file, you just change the extension. So it could be .text or it could be .docx or whatever file format you want to create. Now, what if we want to delete our file? Well, all we have to do is make sure we're in the correct directory to be able to access that file. So when we hit ls, we should be able to see the file we want to delete. And then all we have to do is type rm, which stands for remove, and then we could put our main.py. So there it is, it's gone. Now, what if I want to delete the test folder? Firstly, I have to navigate one step up. Instead of being inside the test folder, I can't delete the test folder while I'm inside the test folder. I have to go one step up, which is the desktop folder. Now, of course, I could say cd into the full path, which is /users/Angela/desktop. Now, this would work, but this is really wordy. A really simple shortcut for navigating just one step up is writing cd space and then 2 dots. This is going to take us to the parent folder, which is now desktop. From here, I'm going to delete this folder. Now, to delete a folder, we can't just put rm. We also have to put a flag, so a dash and then rf. So this is going to recursively, forcibly remove this folder that we're going to add here, which is the test folder. Now, the thing you have to be really careful about rm-rf is it does things recursively. So if there were lots of folders inside this test folder, then it's going to delete everything in there. And if, God forbid, you actually have this and you put it onto your whole computer, well, then that's going to be a real disaster. Because the thing you have to know about the terminal is that it's very powerful. And what did Spider-Man's uncle say? With great power comes great responsibility. There's some pretty funny stories about people who accidentally deleted everything on their computer just by messing with rm-rf. So be really careful that you are in the correct location to delete the folder and to double check that it's the right folder. Because when I hit enter, you can see it's not going to ask me for a confirmation, and it's also not going to put that folder or the containing files into the bin. So be really careful when you're using the terminal. There you have it. There's an introduction to the command line using ZSH on Mac and using the command prompt on Windows. Now, when you open up PyCharm and you go to this emulated terminal, so it's a sort of application within an application, you can see that it looks pretty much the same. Basically, all that PyCharm has done is just bundled the command prompt into the PyCharm on Windows and the ZSH terminal into the PyCharm on Mac. So you can do everything that you can do in the terminal inside PyCharm as well, which makes it really easy to pip install modules or to run our Flask server. Now, if you want to know about other things that you could do in the Windows command prompt or the Mac terminal, you can simply just search for command prompt cheat sheet or terminal cheat sheet. And what it'll take you to are lots of addresses which contain basically a lot more things that you could do with your command line. But the ones that we've talked about today are some of the most common ones, and 99% of the time, those are going to be the commands that you're going to be sticking to. So write them down if you need to, review them regularly, and if you just use them on a regular basis, you won't have any trouble remembering them. Now that we've understood a little bit more about the terminal commands, let's come back to our Flask code and understand what the code is doing in a little bit more detail. For example, what is this name? Because we're creating this app from this Flask class, and in order to initialize a new Flask application, there is only one required input, and that is the import name. Let's go ahead and print it out. So if we print this __ name and comment out the rest of our code and hit run, then you can see that it prints out __ main ___. this name is one of the special attributes that's built into Python. At any given point, you could tap into the name to find out what is the current class, function, method, or descriptor's name. And when we get main, what it's telling us is basically we're executing the code in a particular module. So that means it's run as a script or from an interactive prompt, but it's not run from an imported module. It gives us this code here. If the name is equal to main, then execute something only if it's run as a script. This also takes us to one of the common ways that you'll see people run Flask apps. You'll see if underscore underscore name is double equal to underscore underscore main as a string, so exactly what was printed just now when we printed out this name. Well, if this is the case, then that means we're running the code from within this current file. We're running hello.py. So in that case, we're going to tap into our app and we're going to call the run method. Now, this app.run basically does exactly the same thing as when we went into the terminal and we said Flask run. But notice when we say Flask run, firstly, we have to provide the Flask app environment variable. And secondly, we have to stop the code using Control-C instead of using our normal run and stop. But if we use app.run, we can now use our standard controls. So I can simply hit run to run this hello.py, and it will start serving up our Flask app at this address, just as it did before when we did Flask run. And instead of using Control-C to quit, we can simply use the stop button to stop our Flask application, making it a lot easier. Basically, by providing the name to Flask, Flask will check that this is the current file where the app code is located, and we're not, in fact, using an imported module. For example, if I was to import the random module and I was to print the random.name, then you can see the first thing that gets printed is the name of that module, but the name that's printed from hello.py, which is the file that's being run, is simply underscore underscore main. So this basically denotes the file that is currently being run. And you say run hello, well then inside hello, name is going to be equal to main. The next part of the syntax that might be unfamiliar is this @ sign and something that comes after the @ sign. Now we sort of know what it does. It's basically saying when the user hits up this path, which is what's called the home route, basically when you go to a website, for example, www.google.com, and you go to the first /, well, that is going to be the home. And it knows that when you go there, you want to see the home page. So that's effectively what we're saying here. When the user navigates to our URL with just a /, they want to see the home page, and so we're going to show them hello world. But what is this syntax exactly? Well, this is called a Python decorator, and this is something that you'll see in more advanced Python projects. So what exactly is a decorator? Well, let's imagine that you have a bunch of functions in your class or in your module, and you want to add some functionality to each of these functions. Well, then you might use a decorator function to do that. Essentially, you can think of a decorator function as a function that's going to give additional functionality to an existing function. In order to really understand this, we have to understand a couple of other concepts as well. So I'm going to do a couple of demos in this replit, and if you head to this URL or find it in the course resources, you'll be able to see all the code that I've written in this file. So a long time ago, we learned about Python functions, And we know that a function allows us to have specific packages of functionality, allows us to add inputs to increase the reusability of the function, and also allows us to get outputs from the function, which we can pass into another function or do something with it. As an example, we've got 4 very simple functions: add, subtract, multiply, and divide, that uses all 3 components of a function. Now, what if we wanted to get a little bit fancier? Well, one of the things about Python functions is that they are known as first-class objects, which basically means that you can pass a function around as an argument. Just like what you could do with an integer, a string, or a float, it's treated identically. That means we can take these functions and we can build another function that uses these functions. Let's say I create a calculate function, which takes a calc function and then the n1 and n2. Inside this calculate function, I'm going to call the function that was passed in and give it the values n1 and n2 that was also passed in. So now when I call the calculate function, I'm going to pass in the name of one of these functions and then some numbers. Those numbers are going to become the input for this specified function, and then we're going to return the result of that calculation. So now lower down, I can call my calculate function, pass in the name of a function, so for example our multiply function, and then pass in some numbers, for example 2 and 3. Now let the output that's returned be our result, and let's go ahead and print this result. And you can see we get 6. So basically it has now multiplied 2 by 3. Now, if I change this to one of the other functions, add, and I run this again, you can see instead of 6, I'm now getting 5. The ability for us to treat functions as first-class objects basically means that we can pass them around as if they were just any other argument, like a number or a string or a floating point number. And then later we can activate them by adding the brackets around them and then any necessary inputs. Now, the next concept, which you might have come across, but we haven't really used it a lot, is the concept of nested functions. Functions can also be nested inside other functions. For example, if I create a function called outer function, and this function is just going to print and say I'm outer. Now inside this outer function, I could create another function. So notice the indentation here means that this function is now created inside this function, and I'll call it the nested function. So this function is simply going to print I'm inner, and now we have the problem of trying to call this function. Now, because this function was declared inside this function, its scope means that it's only accessible inside the confines of this function. So if we were to go outside of the function, so by indenting back to the beginning, we try to call this nested function, then it's actually not going to work. We're going to get a name error. It's not defined. However, if we call this function inside this outer function, then it will now no longer generate an error. So let's go ahead and trigger the outer function by calling it in our main.py. And when I run this, you can see it says I'm outer and then it says I'm inner. So this first gets executed and then this. And this I'm inner is being printed when this line is being evaluated. Now, one of the other things you could do is you can actually return a function from another function. Functions can actually be returned from other functions. So if I make a copy of this previous function right here and comment out this other function, and all the steps before. And we only have this bit of active code, then you can see that instead of calling this nested function here, I could also return it as the output. But the important part here is I'm going to get rid of the parentheses, which means I'm no longer activating that function right here. So now when I call this outer function, the output that this line is going to evaluate to is going to become the nested function. So you could almost store it inside a variable. So let's say I create a variable called inner function, which is equal to the output of the outer function, which is basically this nested function that's being returned. Well, then not only can I trigger the outer function, which is just going to give me I'm outer, now I can also trigger the inner function separately by calling it and then adding the activator, which is the parentheses. So now it says I'm outer after it evaluates this line, I'm inner after it evaluates this line. Now, if this is confusing to you, I recommend heading over to the course resources where I've got a link to this Python tutor where I've entered all the code that we've seen just now, and we can execute this code line by line. So you can see that the first thing that happens is it looks at this outer function and it creates a reference to that function. Now next, it's on this line where our outer function is actually being executed because it has the parentheses at the end. So now it's actually going to go inside this outer function and go through it line by line, where it prints I'm outer and then sets up a reference to this second function, which is the nested function. The nested function can now be called by its name, which is nested function. But at the very end of the outer function, that function is going to be the return value, so it's going to be outputted. Finally, we get to the end of this line 9 and we set up a reference from this variable called inner function to this nested function. And finally, when we get to line 10, we trigger that function. So here is our inner function, which points to this nested function. And so when we trigger this inner function, it's the same as triggering the nested function. And that is when we end up going into this function and printing out what it says inside. Have a play around with that to fully get to grips with all the things that you can do with a function. And once you're happy with all of this and you've reviewed it and you understand everything that's going on, then you've got the foundations to head over to the next lesson where we're going to talk about Python decorators. In the last lesson, we had a primer on functions so that we can understand the next step, which is the Python decorator. So we've seen that functions can have functionality inputs and outputs. Functions are first-class objects and can be passed around as arguments. Functions can be nested in other functions. And finally, functions can be returned as the output from another function without needing to trigger it. With these 4 things in mind, we're finally ready to tackle the Python decorator. First of all, I'm actually going to create a Python decorator for you so that we can talk about how it works. Here's what a Python decorator function looks like. We start off by creating just a normal function. Let's say I call it my decorator function. This function is going to take another function as an input. Now, inside the decorator function, I'm going to nest a wrapper function. And this wrapper function is then going to trigger the actual function that was passed in to the decorator function. And at the end of calling all the lines in my decorator function, I'm going to return my wrapper function. But remember, without the parentheses. Now, basically what we've done is we've created a decorator function which can do some stuff and it could control the calling of the function that was passed in. Remember that a decorator function is just a function that wraps another function and gives that function some additional functionality. So that's quite a mouthful, but let's take a look at an example. Let's say that I want to create a simple function, which I'll call say hello. Now, this function is going to be the simplest form of function. It has no inputs and it has no outputs, and all it does is just going to print hello. Now, what if I don't want to run this immediately the moment when I hit run? What if I want to add a delay to this function? Well, one way of doing that would be importing the time module, and then before we print hello, we can go ahead and run time.sleep, and we can sleep for a pre-specified number of seconds. So now when I call this method say hello, and when I run it, you'll see that immediately nothing happens, and then after a 2-second delay, you can see the print hello actually gets triggered. Now, what if I wanted to create a whole bunch of functions, like say bye and say greeting, and I wanted to add a delay onto each of these? Well, then I would have to copy and paste this code into all 3 places. Now, this is a very simple example, but frequently we'll want to add some additional piece of functionality to a number of our functions. So this is where the decorator comes in handy. What we could do is, before we trigger the function that's passed in to the decorator function, we can add the delay. So now, whenever we decorate a function with this particular decorator function, then it's going to delay for 2 seconds before it runs the function. So let's give this decorator function a little bit more of a descriptive name. Let's call it a delay decorator. Well, now what we can do is we can simply use an @ and we can call the delay decorator in front of the methods which we want to delay. So we can add it to all 3 of them, or we can only add it to some of them. But now when I actually run my function, say hello, for example, you can see that this one, because it's got the delay decorator, it's going to wait for 2 seconds before it prints hello. But if I call say greeting, which is the one that doesn't have the decorator above it, then you can see it gets triggered immediately. So this is a really nice way of adding something that you could do before you run the function, or adding some functionality which you can do after the function. Or alternatively, you can modify the function, so maybe you want to run it twice. So now when I say hello, it's going to not only delay by 2 seconds, but it's also going to run it twice. This syntax is what we saw when we were creating our Flask app. It's got the @ and it basically decorates the function below with a decorator function. So putting this function through a machine that could modify the function or add some functionality before or after. Coming back to our definition, a decorator function is simply a function which wraps another function and gives it some additional functionality or modifies the functionality. Now, coming back to this syntax, this @, it's what's known as syntactic sugar. It's some syntax that you can write to make it easier to write an alternative line of code. So let's say we wanted to add the decorator to this say greeting. Well, if instead of using this syntactic sugar with the @ and then the name of the function, we could also just call the name of the decorator, and then we could pass in the name of our function, say greeting, and then we would end up with the decorated function as the output from this method, and we can now call the decorated function with the parentheses. So now we've triggered this say greeting function and we've passed it through the delay decorator. But it's much easier to see at a glance what's going on by using this @ sign, because you can see now you can just trigger this method by its own name, and because the @delay decorator is on top of it, then it's going to go through that filter. I recommend spending a few minutes looking at this code, which you can access at this URL, which is in the course resources, and then trying to recreate this functionality from scratch based on your understanding of what we just talked about. And then once you're done, when we head back to our Flask application, you can now see that pretty much all of the code is easily understood. We know what this __ name refers to. We know that this is a decorator, which is going to make sure that we only trigger this function if the user is trying to access the URL that is the homepage /. If we wanted to create another function, let's call it, this function could also get a decorator. And this decorator will check to see, well, if somebody goes to the URL /by, well, then we're going to be triggering this method. Effectively, the Flask framework is the one that determines which of these methods to call. And these methods are only called when the decorator says it's appropriate to do so. Now, if I go ahead and run this code once more, and we go to the URL that is our server, so this we know is the home route or the home page, but if we go to /by, then we go to the by route, and this method gets rendered. Now, in order to make sure that you get a chance writing decorator functions yourself, if you head over to the next lesson, I've got a coding exercise for you to challenge you to create your own decorator functions. And it's going to be a really useful decorator function because it's going to measure the amount of time that it takes a particular function to run. So for all of that and more, I'll see you on the next lesson.